magnificent liftoff of PSLV C-57 with Aditya L1 on board.
The satellite Xihe, named after the sun goddess in ancient myth, has carried out spectral scanning and imaging of the sun's H-alpha waveband.
Aditya L1 was the first mission to Sun from India, and it was one of the most successful missions from India. It took just 4 months for the spacecraft to reach the destination point called Lagrangian point L1, which is at a distance of 1.5 million kilometers from Earth. And the highlight is this was one of the cheapest missions in the world, with cost of just $46 million. The scientists say it can help us understand about solar activity such as solar wind and solar flares, and the most important thing is it could help us understand their effect on Earth and near space weather. So friends, if India has sent Aditya L1, what are the monumental things other nations have achieved or planning to achieve in solar missions? In this video, let's take a look at 4 critical missions taken by other space agencies based out of Japan, China, Europe and USA. Before we proceed further, I request you to take a moment and subscribe my YouTube channel and share it to your friends. Now going back, let's look at one of the ambitious missions by Japan Aerospace Exploration Agency and NASA called EUVST, Extreme Ultraviolet High Throughput Spectroscopic Telescope Epsilon mission. This EUVST mission will feature one of the most highly sensitive spectrometers, and it's planned for launch in 2026. So one of the important functions of the space telescope is to collect as much solar UV radiation as possible for analysis. One of the specialties of this mission is the telescope can simultaneously observe broad range of temperatures ranging from 10,000 Kelvin observed at chromosphere, which is the second layer of sun's atmosphere, to million Kelvin, which is observed at corona, and even up to 15 million Kelvin observed at solar flares. But what is the final objective of this mission? The final objective is to understand how is the hot corona, the outer layer of sun's atmosphere, created, and how solar winds which come out of corona are created. Also, the other important objective is to find out when and how do solar flares occur. Let's look at next important and ambitious mission, which is from China, which is also planned for launch in future in 2026. This mission, Xihe 2, has some of the unique features which haven't been achieved before. This Xihe 2 probe is the first mission to Lagrangian point L5, so no other spacecraft from any other nation has gone to this point, and China would reach this point for the first time. These Lagrangian points are positions in space where gravitational forces of massive bodies like Earth and Sun produce enhanced regions of attraction and repulsion, and simply put, the spacecraft can stay in this space with less fuel consumption. So this point L5 is about 150 million kilometers from Earth. It's a challenging distance to cover compared to L1 point, which is just 1.5 million kilometers. What is the objective of the space mission? It is to explore the unexplored area, and it will provide new space information compared to any of the previous missions of the world. Secondly, the satellite will enhance China's ability to forecast space weather, and most importantly, it can allow imaging of solar activity at least 3 days before it can be viewed from Earth. And the next important point is it can measure solar wind conditions 4 to 5 days ahead of Earth impact. We still have 2 interesting missions to cover, and I promise these are the most exciting ones, and so watch till the end. The next solar mission is the one of the most complex missions ever launched. It is a solar orbiter launched by European Space Agency in February 2020. This is a very special spacecraft because it has taken the closest pictures of the sun with cutting-edge cameras compared to any other spacecraft. Also, it has reached a distance of 40 million kilometers from the Sun star, which is closer than the orbit of Mercury. This is the closest spacecraft has ever reached, with an exception to Parker probe by United States, which we will see next. The next important thing is, during such close approaches to Sun, it experiences temperatures of over 700 degrees Celsius, and sometimes a few instruments of the satellite need to be exposed outside the temperature for a brief period of time. To protect instruments from intense heat, European scientists have developed innovative technological solutions to keep the instruments and cameras cool. The satellite has 10 instruments, and 6 of them are telescopes which look at sun's surface in different wavelengths, and 4 of them measure properties of environment around solar orbiter. So what is the core objective of the solar orbiter? Well, they have multiple objectives, and first, to understand what drives the solar cycle. The sun's magnetic field drives 11-year solar cycle of activity, but why that happens is a mystery. Secondly, the scientists want to understand what is exactly going on at the poles. Thirdly, it is a great surprise that sun's surface is colder than the corona, which is the outer atmosphere, and the corona's atmosphere is a staggering 1 million degrees Celsius. This is the other mystery scientists want to find out. Finally, and most importantly, our planet is part of sun's outer atmosphere called heliosphere. Scientists couldn't figure out why solar winds particles travel at blazing speeds of 800 kilometers per second, and this is another aspect of this mission. So far, the images sent by Solar Orbiter helped in discovering new solar phenomena called campfires, which are smaller versions of solar flares. Finally, we are in the last section, and here we are going to know about an interesting solar probe launched by NASA in 2018. This is the Parker Solar Probe, and it is going to achieve the remarkable feat of being the closest probe to the Sun by end of this year, around December 2024. It will reach a distance of 3.83 million miles from the Sun, the closest ever approached by any satellite. It is almost like landing on the star, but the challenge will be huge. It has to withstand a temperature of 1400 degrees Celsius. So it was designed with cutting-edge thermal engineering to protect itself from the scorching heat of the sun. This probe doesn't have sun-facing cameras due to tremendous heat it will experience, but it has 4 instrument suits to study magnetic fields, plasma, and energetic particles. The objective of this mission is to study the workings of the corona and understand solar processes in detail, since it will be the closest human-made object to the sun. This will in turn help to improve forecasts of solar behavior and understand space weather. That's it from me for today, guys. I hope you find this video interesting. If you had more information about the space probes, please comment below. If you find this video valuable, please subscribe my YouTube channel and share it to your friends. Small actions like these will motivate me to create more such videos. I will meet you in next video, and until then, take care. Bye bye.